Hello everyone, in this video let me solve GATE 2019 year engineering mathematics questions related to the topic calculus subtopic maxima and minima. I already uploaded the concept video in my YouTube channel. I gave the concept video link in the description box. Keep watch if you want to. Now let's move on to the problem. The maximum value of the function f of x equal to x e power minus x, where x is real, is what? You have to find the maximum value of the function f of x. This question is from AE department. It has 1 mark. First, f of x is given. You have to find f dash of x. F dash of x, d of uv, formula of d of uv, u into dv, that is u is x, e power minus x, differentiation is minus e power minus x. Next, plus v du, du is 1 e power minus x. Next I find the critical point, so I solve the equation f dash of x equal to 0, minus x e power minus x plus e power minus x equal to 0. Here e power minus x is common, so I took outside 1 minus x. Here 1, this is minus x equal to 0. In what values this equation becomes 0? X equal to 1. That means e power minus x equal to 0 or 1 minus x equal to 0. So, in what value e power my x, in what value of x e power minus x is 0, e power minus infinity value equal to 0. So, x equal to, in that case x equal to 1 and infinity. Okay, so the critical points are 1 and infinity. In this place, in that problem, I use second derivative test. What is second derivative test? Suppose f double dash is continuous near c. C is a critical point. First one is if f dash of c equal to 0 and f double dash of c greater than 0, then f has a local minimum at c. Okay. Next, if f dash of c equal to 0 and f double dash of c less than 0, then f has a local maximum at c. So here I use second derivative test. So I find the f double dash of x, that is here uv formula minus x e power minus x, differentiation is minus of e power minus x. So here I got plus e power minus x. Next, minus e power minus x into that value is 1. Next, e power minus x differentiation is e power minus e power minus x. So the final answer is x e power minus x minus 2 e power minus x. This is f double dash of x. I substitute the value of critical point in f double dash of x. Critical point in f double dash of x. First I substitute f double dash of 1. This is equal to x1 e power minus 1 minus 2 into e power minus 1. This is 1 by e minus 2 by e. So finally I got minus 1 by e. This is less than 0. F double dash of c less than 0, then f has a local maximum at c. So in that problem, f of x has a local maximum because f double dash of 1 is less than 0. So f of x has a local maximum at x equal to 1. Local maximum at x equal to 1. So you have to find the maximum value of the function f of 1, f of x. So I find f of 1. 1 into e power minus 1. This is 1 by e. So the final answer is option A. Option A is the correct answer. Second problem is, which one of the following is not correct statement? Okay, you have to find which one of the following statement is not correct, wrong statement. This question is from CE department. It has 1 mark. The first two statements has the function xth root of x, xth root of x. So first I take the function f of x equal to xth root of x. Here, first I find the f dash of x. How to find the differentiation of this function, xth root of x? Here, I named this function as y, xth root of x. Taking log on both sides, then I got log y equal to log of x root of x means x power 1 by x. So by using logarithmic rule, 1 by x into log x, I can write this function becomes taking log on both sides, log y equal to 1 by x log x. Then I differentiate. I got log y differentiation is y and y differentiation is y dash. This is equal to, here I use uv, d of uv formula, 1 by x, log x differentiation is 1 by x plus log x, 1 by x differentiation is minus 1 by x square, x power minus 1. X power minus 1 means minus 1 into x power minus 2, that is minus 1 by x square. So y dash equal to y into, what is the value of y? X power 1 by x, this is y, into 1 by x square minus 1 by x square log x. Next I find the critical point. How to get the critical point? Y dash equal to 0. I take y dash equal to 0, y dash of x equal to 0 gives, in what value of x y dash becomes 0? Log e value is 1. So 1 by x square minus 1 by x square equal to 0. In that case only y dash equal to 0. So at x equal to e, y dash of x equal to 0. So x equal to e is a critical point. Is a critical point. Next I find the y double dash, because here I find the global maxima or minima. So here I use second derivative test. That is, suppose f double dash is continuous near C. If f dash of z equal to 0 and f double dash of z greater than 0, then f has a local minimum at C. Less than 0, then f has a local maximum at C. So in that place I find y double dash. How to find y double dash? Y dash is here. First, I write u is x power 1 by x. I differentiate this function, that is minus 2 by x cube minus 1 by x cube, because 1 by x square into 1 by x value, or log x differentiation is 1 by x minus 1 by x cube plus 2 by x cube log x. Next, I write this function is same, x power 1 by x differentiation is again this one. So I can write this is x power 1 by x, 1 by x square minus 1 by x square log x whole square, log x whole square. Next I find y double dash of e. Y double dash of e, I substitute the value of x in y double dash. I got this value is log e is 1, 1 by x square minus 1 by x square 0. So the total value of this term is 0. Next I substitute here e power 1 by e. This is minus 3 by x cube. Here log e is 1. So 2 by x cube cancel. This only is available, that is minus 1 by e cube, minus 1 by e cube. Finally, I got this is less than 0 because the negative value. So this is less than 0. Y double dash is less than 0. Then function y has the local maxima at x equal to e. Y has the local or global. This is global, absolute maxima. Global maxima at x equal to e. So the function x root of x has the global maxima at x equal to is the correct statement. But the option B is the wrong statement, because the option B is the function x root of x has the global minima at x equal to e. But the correct statement is global maxima at x equal to e. So this is the only wrong statement. I don't need to check these two statements because this is the wrong statement. So this is the answer. Answer B is the correct answer. Third problem is, for x in 0 comma pi, the maximum value of the function is sin x plus cos x is what? This question is from TF department. It has 1 mark. F of x is f of x equal to sin x plus cos x. Next I find f dash of x. This is equal to cos x minus sin x. Next step is find the critical point. Equate the function f dash of x equal to 0. I got cos x minus sin x equal to 0. So cos x equal to sin x. In what value of x? Cos x equal to sin x, x equal to pi by 4. Otherwise cos x sin x by cos x equal to 1, that is tan x equal to 1. In what value of x? Tangent value is 1, tan function is 1, x equal to 45, that is pi by 4. So x equal to pi by 4 is a critical point. End points are 0 and pi. So I find the maximum value of the function. So I find all the values of f at the points, critical point and end points. First I find f of 0. F of 0 is sin 0 plus cos 0, that is 1. F of pi by 4, this is root 2. 1 by root 2 plus 1 by root 2. Cos pi by 4 is 1 by root 2. Sin pi by 4 also 1 by root 2. So this is root 2. Next, f of pi. Next endpoint is f of pi. F of pi equal to minus 1. I have to find maximum value of f. Here root 2 is 1.414. So the maximum value of f is this one. This is maximum value. So the final answer is option C. Option C is the correct answer. The fourth problem is the number of critical points of the function f of x comma y equal to 1 2 variable function is given at which there is neither maximum nor minimum is dash. Here I have to find f has a neither maximum nor minimum at what are the points. This question is from XC department. It has 1 mark. Here 2 variable function is given. So in that place I use second derivative test in 2 variable function. Suppose the second partial derivatives of f are continuous, then fx equal to 0 and fy equal to 0 and a comma b is a critical point of f. Let d, what is the value of d? fxx fyy minus fxy whole square. Suppose if d greater than 0 and fxx also greater than 0, then f of a comma b is a local minimum. D greater than 0 and fxx less than 0, then f of a comma b is a local maximum. D is less than 0, then f of a comma b is not a local maximum or minimum. This is the second derivative test of two variable function. Now f of x comma y is given. Next I find the inflection points. So I solve the equation fx equal to 0 and fy equal to 0. So I find fx and fy. What is fx? 3x square plus 3y square minus 15 fy equal to 6xy minus 12. Next I find fx equal to 0, solve fx equal to 0 and fy equal to 0. Fy equal to 0 gives 6xy equal to 12, that is xy equal to 12 by 6, 2 gives y equal to 2 by x. Substitute the value of y equal to 2 by x in fx equal to 0 equation. I got 3x square plus 3y square. Y square is 2 by x whole square. Next minus 15 equal to 0. I simplify this equation. Finally, I got the equation x power 4 minus 5x square plus 4 equal to 0. Solving this equation, this is a polynomial of degree 4. Solving these two, we get x square equal to 1 and x power 4 equal to x square equal to this is square. X square equal to 1 and x square equal to 4. So x equal to plus or minus 1 and x equal to plus or minus 2. These four values are the solutions of this equation. Substitute x equal to 1. I got x equal to 1 gives y equal to 2. So the point is 1 comma 2. Similarly, I substitute x equal to minus 1. I got y equal to minus 2. The point is minus 1 comma minus 2. Next, x equal to 2. Then I substitute this place 1, y equal to 1. So 2 comma 1. Next x equal to minus 2. I substitute that value -1. So the point is -2 comma -1. These 4 points are the inflection points or critical points. Okay. Next, I find the value of D at that points. Then only I conclude D less than 0 points are the not a local maximum or minimum. Okay. At that place, F has not a local maximum or minimum. Okay. So I find Fxx because D involve Fxx involve D. Okay. So Fxx, what is Fxx? Equal to 6x and Fyy equal to, this is also 6x. Fxy, what is Fxy? Fxy equal to, this is 6y. Next, D equal to Fxx into Fyy, that is 36x square minus Fxy whole square, that is 6 or 36y square. First, I substitute the value of 0.1 comma 2 at D, that is D of 1 comma 2. D of 1 comma 2 equal to negative, okay, less than 0. So in that place, F has neither maximum nor minimum. Next, I substitute the point -1 comma -2. This is also negative less than 0. So in that place, F has neither maximum nor minimum. Next, D of 2 comma 1. This is positive greater than 0. D of minus 2 comma -1. This is also greater than 0. In that place, I have to check next step, Fxx. That is, it is not need, because these 2 points only has not a local maximum or minimum. Okay, so the number of critical points, the function f of x comma y at which there is neither maximum nor minimum is 2, that is 1 comma 2 and -1 comma 2. These 2 points not a local maximum has, in these two, at these 2 points the f of x has not a local maximum or minimum. So the final answer is 2. These are the GATE 2019th year engineering mathematics questions related to the concept calculus, main concept calculus, but particularly maxima and minima. If you have any doubt in this concept, then you can ask in the comment section. Let me try to clarify your doubts. Thank you. See you in the next video. If you like this video, please like, share and subscribe my channel to encourage me. Thank you.